Hello, happy Mole Day, everybody. So you might need to convert between the number of moles of a substance and how many little things are there. So the little things, they could be called molecules, right? We could be talking about molecules of water. The little things, we could be talking about atoms. So if we were talking about maybe a noble gas or a metal, or what about the hydrogen atoms in the water? You could talk about that, or you could talk about the oxygen atoms in the water. Or if we're looking at sucrose, carbon, hydrogen, or oxygen. Or we could be talking about the formula units, right? The little things could be formula units instead of these other two. Formula units is the word that we would use if we were talking about an ionic compound. So NaCl, right? We might talk about atoms of sodium or atoms of chlorine, even though they're ions. We might talk about atoms, but we wouldn't call this a molecule, right? We would say a formula unit. So that term is for ionic compounds. So if you're going to convert between moles and these really tiny things, then you're going to use Avogadro's number. So we're going to use Avogadro's number to make conversion factors. These are the two conversion factors you can make. So 1 mole is this many of anything, or this many of anything is 1 mole. These, since what's in the numerator equals what's in the denominator, this is an appropriate conversion factor. So let's try a couple. So number 1, how many molecules of water are in 2.5 moles of water? So I wrote what I'm starting with 2.5 moles of water, and I'm going to put a conversion factor next to it. Moles of water is in the numerator, so if I'm going to get rid of this unit, I need it to also be in the denominator. And 1 mole. A little bit out of room, but there we go. So if we just take a calculator, although we probably don't need it for this one. So 1.51 times 10 to the 24th molecules of H2O. Next question. How many atoms of carbon are in 0.750 moles of sucrose? So notice this one, we're not talking just about the molecule overall, we're talking about a specific atom inside there. So there's going to be an additional conversion factor you're going to use. So let's get started. We got moles. First conversion factor is going to be Avogadro's number. Moles of sucrose is in the numerator. Again, we need it in the denominator. And we're not done because the question is atoms of carbon. So we need to create a conversion factor between molecules of sucrose and atoms of carbon. One molecule of sucrose has 12 atoms of carbon. Okay, so I'm going to get rid of the water. Right, so 0.75 moles, we go from moles to molecules of sucrose, and we go from molecules of sucrose to atoms of carbon. So we just 5.42 times 10 to the 24th atoms of carbon. Okay, so that's if you're figuring out how many of these small things do you have from moles. Right? We usually count things in moles. A lot of times we're more concerned with moles than thinking about individual molecules just because there's so many, right? This number is so big. But you might be asked that question, and this is how you do it. So then there's also going back, or going the other way. So what about if we ask this question? How many moles of water is equal to 10 to the 9th molecules of water? 10 to the 9th is a billion. So you think a billion is a large number. Okay, we have a billion molecules. How many moles is that going to be? And get rid of this. All right, get rid of Y. Again, we're going to use Avogadro's number to make a conversion factor, but now we have molecules in the numerator, so we need molecules. We need molecules in the denominator. So 10 to the 9th, you can see this is going to be a pretty small number. If you're putting this in your calculator, please write 1E9. Not 10E9. So this is 1 times 10 to the 9th. So make sure you don't mess that up. So billion, big number, but not so many moles of water, 10 to the negative 15th.